Your air conditioner has never made cold air. Not today, not once, not ever. In fact, and I need you to stay with me for about 8 seconds here, the machine bolted to your window is technically a heater.
I know exactly how that sounds. It's blistering outside. You walk into an air-conditioned room, and it is unmistakably, gloriously cooler. So how on earth can the thing making that happen be a heater?
Because cold is not a thing. You cannot manufacture it, you can't bottle it, you can't blow it into a room. There is no tank of cold hiding inside that box. Cold is simply the absence of heat. And that changes everything about what this machine is actually doing.
What your AC is really doing is far stranger than cooling. It is reaching into your air, grabbing heat molecule by molecule, and marching it out the window against its will. And by the end of this video, 3 things are going to click into place. 1, the single bizarre property of liquid that makes the entire trick possible. 2, why there's water quietly dripping out of the unit, and why that drip is the whole reason air conditioning was invented in the first place. And 3, the genuinely uncomfortable reason that cooling your room is making your entire city hotter.
Here's the tell that this was never about cold. The very first modern air conditioner, built by an engineer named Willis in 1902, wasn't trying to cool anyone down.
It was installed in a Brooklyn printing plant to solve a paper problem. Humid air was warping the pages and smearing the ink. Carrier's machine was built to control moisture. The cooling was almost a side effect. Hold on to that. We come back to it, and it's the key to the whole thing. Quick experiment you can run right now. Touch a metal doorknob, then touch a wooden chair right next to it. The metal feels colder, right? Except they're not. Put a thermometer on both, and they're the exact same temperature. The metal only feels colder because it pulls heat out of your hand faster.
You are never sensing cold. You are sensing heat leaving you. That's the rule the entire universe runs on. Heat only ever flows one direction on its own, from hotter to colder. A hot coffee cools down. It never spontaneously gets hotter by stealing warmth from the cold room. Heat rolls downhill every single time. So here's the problem an air conditioner has to solve. Your room is warm. Outside is even warmer. To cool the room, you have to push heat out, from cooler to hotter. That's uphill. That's the universe saying no. The only way to move heat uphill is to force it, to spend energy shoving it the wrong way. And that's the honest definition of your air conditioner. It is a heat pump, not a cold maker, a pump. It takes heat that does not want to leave, and it pumps it out of your house. But that raises an almost impossible question. Heat isn't a thing you can grab with your hands. It's not a liquid you can scoop. So how do you physically get hold of it and drag it outside? The answer is a liquid with a genuinely strange superpower. Ever stepped out of a pool on a hot day and suddenly felt freezing? Or had a nurse swab your arm with alcohol and felt that cold sting? Nothing got colder around you. What happened is that the water or the alcohol evaporated. And to turn from liquid into gas, it had to steal heat from your skin to do it. That is the entire secret. Turning a liquid into a gas soaks up an enormous amount of heat. Scientists call it the latent heat of vaporization. And it does it without the liquid even getting hotter. All that energy goes into the transformation itself. So engineers went hunting for a liquid that would do this on demand. They invented refrigerant, a fluid designed to boil at absurdly low temperatures. We're talking so low that even the cool air in your room is hot enough to make it boil instantly. So picture what's happening behind that indoor vent. Cold liquid refrigerant floods a coil. Your warm room air blows across it.
the refrigerant boils, and as it boils, it drinks the heat straight out of your air. The air that comes out the other side has had its heat stolen. That is the cool breeze on your face. It's not cold being added, it's heat being removed by a boiling liquid. But now you've got a real problem. That coil is full of gas that's absolutely loaded with your living room's heat. You can't just leave it there. You have to dump it somewhere. And that is the job of the big, loud box outside. Walk past the outdoor unit of an AC on a hot day and hold your hand near it. It's blasting out hot air. People assume it's just the machine running hot. It's not. That heat has a return address. It's the heat from inside your house being evicted. Here's the round trip. The heat-loaded gas gets pulled into a compressor, which squeezes it hard. And squeezing a gas makes it even hotter. Now hotter than the air outside. Now that it's hotter than outside, heat can finally flow downhill again, out of the gas into the outdoor air. That happens in the condenser coil outside, and as the gas dumps its heat, it condenses back into a liquid. Then, it passes through an expansion valve that drops its pressure and temperature back down to freezing, ready to boil and drain heat all over again. That's it. That's the whole machine. The same refrigerant looping forever, running a shuttle service. Pick up heat inside, drop it off outside. Come back, repeat. Thousands of times an hour. It never makes cold, it just never stops carrying heat out the door. But there's one more thing coming out of that machine that we haven't explained. It's not heat, it's water. And it's the reason air conditioning exists at all. Look under almost any AC unit and you'll find it. A steady drip of water, a little puddle. Most people assume it's a leak. It's not a fault. It's the machine doing half its actual job. Remember Carrier's printing plant in 1902? The whole point was never temperature, it was humidity. And here's why your AC removes it automatically. Warm air holds a lot of water vapor, but when that air hits the freezing indoor coil, it can't hold the moisture anymore, so the water condenses right out of it. Same reason a cold glass of water sweats on a summer day. And this matters more than you'd think, because a huge part of feeling cool isn't the temperature at all, it's the dryness. Humid air stops your sweat from evaporating, which is why 30 degrees in a jungle is misery, and 30 degrees in a desert is fine. So your air conditioner is secretly a dehumidifier, and that drip outside your window? That's comfort you can actually see. Come back to that very first claim. Your AC is technically a heater. Now I can prove it. To pump, say, 3 units of heat out of your room, the machine burns roughly 1 unit of electricity to run the compressor. And that electricity, it doesn't vanish. It also turns into heat. So what actually gets dumped outside isn't 3 units. It's the 3 units it moved plus the one it burned. 4 units out for 3 units removed. Every air conditioner, without exception, ejects more heat into the world than it removes from your room. On the scale of your bedroom, who cares? But we don't run one AC. We run hundreds of millions of them, packed into cities, all blasting their exhaust into the same streets. And researchers have measured what that does. A study out of Arizona State University, modeling the Phoenix metro area, found that the waste heat from air conditioners raise nighttime outdoor temperatures by around 1 degree Celsius across parts of the city. Sit with what that means. Everyone's AC heats up the shared outdoor air. Hotter outdoor air makes everyone's AC work harder, which dumps more heat outside, which makes it hotter still. It's a self-feeding loop. We are, in a very real sense, air conditioning ourselves into a warmer city. And there's a quieter problem hiding in the refrigerant. Those fluids are miracle heat carriers, But many of them, if they leak into the atmosphere, are greenhouse gases thousands of times more potent than CO2. The common refrigerant R410A traps heat roughly 2,000 times more effectively than carbon dioxide, pound for pound. Globally, the International Energy Agency estimates air conditioning already eats about 7% of the world's electricity.
Now, I'm not here to make you feel guilty for turning on your AC. That's the wrong lesson, and it lets the interesting idea slip away. Because every fridge, every freezer, every heat pump on Earth works on this exact principle. The real takeaway isn't AC is bad, it's something deeper about the universe. You cannot destroy heat. You can only move it somewhere else. And somewhere else is always someone's outside. The problem was never the machine. It's what happens when millions of us relocate heat into the same shared air.
And the honest good news? This is being addressed. International agreements are phasing out the worst refrigerants, and newer, far less harmful fluids are already replacing them. The physics stays the same. The chemistry is getting smarter.
So here's the single reframe to walk away with, and it'll change how you use your AC tonight. Stop thinking of your thermostat as a cold dial. It isn't adding cold. It's setting how hard the machine has to pump heat out of your house, and how much heat is trying to sneak back in. Which means the highest leverage thing you can do isn't cranking the dial lower. It's stopping heat from getting in the first place, closing blinds against direct sun, sealing the gaps around windows and doors. You fight the heat at the door, instead of paying to pump it back out after it's already inside. Try it tonight. Nudge the thermostat up a degree or two and block the sun instead. Same comfort, a fraction of the work. And here's where it gets fun. If an air conditioner always dumps more heat than it removes, then think about this. What would happen if, on a hot day, you just left your refrigerator door wide open to cool down the kitchen? Almost everyone is completely certain they know the answer, and almost everyone gets it wrong, for the exact reason we just spent 10 minutes on. It's the cleanest, weirdest demonstration of everything in this video, and it's the one playing right here.